If it's on us, if we did something wrong in assembly, if it's a labor thing, we eat it. And it's been some really tough lessons. I will tell you, at one point in the V10 engine building experience, we probably had $1 million mistake,
Oof.
which almost ruined us.
Welcome to the HPA Tune In Podcast. I'm Andre, your host, and in this episode, we're joined by Martin Musial from AMS Performance in the US. Now, AMS is, I'm assuming here, a name that almost everyone is familiar with. They're probably one of the most prominent performance workshops, building high-quality, reliable packages at different stages for a huge range of popular performance vehicles. Now, interestingly, Martin and AMS actually were one of the companies that we looked up to in the early days of my old business, STM. They, at the time, were deep in development on the Mitsubishi Evo platform, and their Evo 8, I believe it was, held the world record on the quarter mile with an 8.42. And I had a customer come to me and said, I want to beat that car. And that seemed like a tall task at the time, but long story short, we actually did manage to do that. So there was some friendly rivalry, I think, between AMS and STM. We got that car to beat the world record with an 8.34 at 169 mile an hour. These days, AMS has moved on from the old Evo platform and are probably now best known for their work on the R35 GTR and more recently the Lamborghini Huracan and Audi R8 platform. So we talked to Martin about his background, how AMS was formed, how they develop these products, and how they choose what vehicles are going to be supported. We also get deep into the world of tuning on some of these late model cars and some of the intricacies when it comes to setting these very powerful 2,000 plus horsepower Lamborghinis and R8s up for performance on the drag strip and roll race half mile events. Before we jump into our chat, for those who are new to the Tune In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools or just about anything in between. They are great prizes and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, Martin, this is one that I have been very excited to have you on board. Let's start as we always do. Let's find out about your background and how you got interested in cars.
Well, to go way back, my dad was always into cars. He's a mechanical engineer. He's Polish, old school European guy, but he was always trying to make some money. He'd buy old cars, fix them up, and at one point he would travel actually to Germany with his buddies. They'd buy cars in Europe, bring them back here, like 1-year-old used cars, bring them back here, convert them and sell them, make money. So I remember just seeing these cool cars that they'd bring back like a Mercedes or Porsche, but then some laws changed, that kind of ended. But that I was kind of, let's see, that probably started my really passion kind of for cars, but I was always into mechanical things, always taking things apart.
What sort of age are we talking here? Like, are we teens or preteen?
Oh, I think I was probably like 6 or 7 years old, and I was taking apart my parents' thermostat and like iron, my mom's iron, taking apart and putting back together. So that mechanical tinkering started super early. But yeah, like the car stuff was probably, I was in middle school, so like little preteen, early teens. That's when I started. Then of course, once I got my license, my parents had the worst cars. Well, I'd say the worst cars, but yeah, they're pretty bad. A Peugeot 505.
Interesting choice.
Yeah, yeah, little 4-cylinder manual. Super slow, still got me into trouble, but so I was like, oh man, I can't wait to get my license. My dad had all these cool cars, and no, those are all gone by then. He just had boring cars.
I think the difference between my daughter is coming up in another couple of years' time to get her license, which scares the absolute shit out of me, if I'm honest. And I look back at what I had access to when I was learning to drive. And the cars were so slow that if you got yourself into trouble, you'd probably take your seatbelt off, open the door, get out and walk away before it hits the tree. And now that's not the case. So, things have moved on, sometimes for the better, mostly for the better, but sometimes for the worse as well. So sorry, carry on.
Yeah. My son's going to be driving in 2.5 years too, so it's pretty scary. But yeah, no, so that's what kind of got me into cars, and I went to school for mechanical engineering, graduated, and I wanted to work for something, car manufacturer, a race team or something. And I looked at the car manufacturing, the big three OEMs, and people I talked to like, oh, you'll be designing a doorknob for years or something. I'm like, that's not.
I can't see it being too exciting, spending 3 years of your life designing a tail light, for example, for the latest Ford F-150 or whatever it might be. That's not going to spin my wheels.
Yeah, exactly. So, but I was graduating, and my father at the time, he started a machine shop, a tool and die shop, a few years like when I was in college, and it was just him and his business partner, and his business partner quit, basically, walked out. My dad said he went crazy, but I think my dad maybe drove him crazy. So he was by himself, and he's like, hey, I need your help. When you graduate, can you come, work for me? And I couldn't say no, because my dad helped me out with college, paying for stuff there. So I could not say no. So I worked for my dad for a few years, lived at home, learned a lot of hands-on stuff, like I had to, design and machine parts. So I designed this tooling and then had to make it myself. And I quickly learned, as an engineer, you can design some really cool shit, but can you make it? So
are we talking here CAD and CNC, or is this a bit more old school?
No, not even CNC. No, it was. We had these machines called 4-slides where they made little like wire forms and linkages. And no, it was 2D CAD back then. It was AutoCAD. And then I literally had to make all this stuff on a manual mill. So I learned, manual mill, lathe, tooling. We get stuff sent out to get, maybe wire EDM'd or stuff like that for dies. But it was all, no CNC work back then. So it was pretty simple. My dad and I had very different business mindset. My dad is very old school. The harder you work, the better. It was his philosophy. And I was a little bit like, well, let's focus our hard work on maybe things that can be better for us. So we had some differences there. Working with family is not always easy, but I learned a lot. I'm grateful for that.
I think the old working hard is not always the way to get ahead. It's about working smarter, but sometimes, particularly if you've been in it for a long time, and I obviously don't know much about your dad's business, but maybe sounding like that was what it was. You sort of can't see the wood for the trees, and sort of getting to work smarter rather than just working harder is the way to get forward.
Yeah, it's a combination of both. And I remember we bought some clapped out machine for like 10 grand, and we spent a whole summer rebuilding it. And then once we rebuild it and things are good to go, then we can go look for a job. I'm like, how about we find the job? And then we could just buy a machine that's not clapped out, save us the 4 or 5 months of agony.
Yeah.
So, but again, it all worked out because, I always loved cars. So kind of on the side, I was playing around with cars a little bit. And I had my childhood friend Arnie, he had a Merkur XR4Ti, which is a 2.3 liter 4-cylinder turbo, single overhead cam, pretty rudimentary car. I had one in high school for a little bit, then he bought one after graduated college, and We started tinkering with it. I started the business technically with a NASA scientist, believe it or not. It was,
Wow.
it was back in the day, online like forums, and we knew what we were talking about as far as like mechanic wise and car wise. So we kind of hit it off, and we are talking like, hey, this car really needs this 2.3 liter turbo Ford, really needs a camshaft. So we took a camshaft design class. I actually did my senior project in college was designing a camshaft, industrial camshaft, not a engine camshaft, but still gave me some fundamental knowledge. And it was not computers, all hand equations to design like a cam with all the take-up ramps and all that stuff was pretty crazy, pretty wild. But
is this back in the day before there were catalogs where you could just go to Calford or any of the other comp cams manufacturers and just choose from a catalog of cams for that vehicle? You're kind of breaking ground on this?
There was nothing for that,
Okay.
that vehicle at all. So yeah, we designed a cam and it worked real well. Was it Fast Forwards and Muscle Mustangs, I think was the first magazine, and someone tested it and they posted the results, and it was like a great cam, kind of all around. It made more power, wasn't too aggressive, and that was kind of our first product as a company. And my partner at the time, he was again working for NASA full time in California, and I'm like, hey, I want to do more. He's like, all right, I see this is a business you want to go after. This is so we kind of like, he's like, hey, just let's split that. You take this further because I'm just, I got a full-time job and everything. So
he's putting shit into space. You're making camshafts. I get it.
yeah. It's, he's saving lives, burning rubber. So yeah, so that's kind of how it started. It was our kind of technically our first product camshaft, and then from there, my dad had we were supposed to get a job that fell through. So he had a space we rented next door. It was like 1,500 square feet. We had a 6-month or a year lease. We had a sign on it. It was empty. I'm like, hey, I want to start working on some cars. So business was kind of slow. I was living at home, not making any money. I was just helping him out. And we just started playing around with DSMs, Mitsubishi, the Eclipse, the Eagle Talon, Plymouth Laser, turbo 4-cylinders.
That was arguably an amazing platform to start with modification. It's still to this day, I look at that platform. Obviously, we didn't get DSM Eclipse in New Zealand. We had the JDM models, but essentially, let's call it an Evo 1, 2, 3, 4, etc. Same 4G63. Well, actually, no. Let's start with the Galant VR4, which is what we had. But I mean, you've got a platform there that. And I still to this day do not understand why it was so over-engineered for what was, I think at the time, maybe, what were we talking, 250, 300 horsepower off the showroom floor?
I think 220 or 240.
Maybe 220,
Yeah. It was an awesome platform, man. I love turbocharged, whole concept of that. And, that kind of, I learned a lot there from anywhere from tuning to wrenching on the car. So I was like, in the beginning, I was the mechanic, I was the tuner, and then.
So you've got no formal qualifications as a mechanic. Everything you're doing here, despite your mechanical engineering degree, the actual wrenching on the cars, this is all self-taught.
Yeah, I mean, I did Formula SA in college. So we built a little like mini formula car around a motorcycle engine, but that was the extent of. I mean, I've always tinkered, like self, working on stuff here and there, but yeah, completely self-taught.
Side quest here though, and I'm interested to get your take on it because my pathway was similar, although frustrated to this day in New Zealand being such a small country, we didn't have at the time. The university that I went through at least didn't have a Formula SAE team. And I've said this on the podcast before, I imagine more than 50% of the guests that I have on board have gone through Formula SAE. So to me, it's still something that I wish I'd had access to, but didn't. Anyway, where I'm going with this is, and this is probably going to piss off a lot of qualified mechanics out there. I think the process you go through to become a qualified mechanic doesn't perhaps set you up that well for the performance side of automotive. And these days, I think it's actually becoming worse because I see now a lot of mechanics coming through. Servicing vehicles has become less, other than doing your usual oil and filter changes. There's not a lot of diagnostics of deep mechanical issues. And if it is a deep mechanical issue, it's usually like, oh, we're going to take the engine and put a replacement in. So I think a lot of the skills that maybe you and I learned back in the day through hard-won sort of time and effort has to a degree been lost. I don't know. What's your take on that?
I would agree. We hire, start here. Like, so we had to figure out the hard way. No one showed me how to do all this stuff. I had to do it the wrong way and figure out why it was wrong, then do it the right way. Or I had to figure out how stuff worked. And that's one thing that, I've always been good at. I can't say I'm not crazy intelligent. I don't get things like, oh, I see something, oh, I just know how that works. No, but I can figure it out, and I have that drive I have to learn this. I can figure it out. I'll get good at it. And that goes along with like debugging. We hire mechanics. I would say from a dealership or more of like a technical or like a program, like school taught mechanics, that debugging or that kind of thought process, I would say is not there, because a lot of it is you understand the mechanical stuff, how it works, how to change parts out, but then a lot of it is referring to, a guided, was published, okay, change this part out, then change this part out, then change this part out. And so we've, like, for example, in the V10s, we've had to figure out how that transmission works. That DL800 transmission is not technically a serviceable transmission. So when the dealer gets a car that has a transmission issue, they just pull the whole thing out. Here's a $50,000 new trans, right? We had to figure out how the whole thing works. And we've actually had dealers send us cars, hey, this thing has this issue. This customers want to buy you trans. Can you guys do this? We take it apart, we figure out what's wrong with it, and it's instead of a $50,000 trans, it's maybe $4,000.
Is that different? I think we're going on a side quest here, but let's continue. I think that whole landscape has changed now. And I'd say probably Dodsons here in New Zealand are probably a big driver in this, because obviously these transmissions now have become so popular for going 200 plus mile an hour in the quarter mile, half mile, and as you say, non-serviceable. But now Dodsons are actually making replacement parts because obviously all of the internal components are not up to 2.5, 3,000 horsepower. So now you actually have options to service even at a lower power level, clutches, baskets, etc. So has that kind of changed the game a little bit into what was previously like take it, chuck it on a pallet, throw it in the rubbish and order a new one from Audi, Lamborghini?
100%, and that would stop progress because you couldn't make parts, you couldn't go faster. You're afraid to push it faster because when it breaks, then you got a pissed off customer and and so you couldn't make more parts because that was holding it back. So that definitely,
the transmission was always the limiting factor.
Yeah, it was, but we did go down a little side quest there, but I kind of summarize like my beginning is like, I would do a lot of the job myself first. I learned how to weld. I learned how to wrench on the cars, learn how to tune, and I would kind of hire for each position and replace myself with someone or find someone that was ideally better than me.
Well, I think that's the entrepreneurial outlook as well. Like, I think you need to have an understanding of every part of the business, and I think it's beneficial if you work in every part of the business, but you also do not have to be expert level at each part of the business. What you need to find is, what does that part of the business require? And then if you're doing your job properly, what you're going to do is hire someone that is superior to you for that part of the business. And I think if you do it right, that's how it should go. It doesn't always work that way.
No, you have to know enough to know if you're being bamboozled, right? I found frustrating sometimes because I don't want to learn this, right?
Well, each of those individual parts is, if you want to become expert level at tuning, at fabrication, at whatever it may be, the old story, 10,000 hours to become expert at any of those parts. And I mean, we as an entrepreneur do not have the ability to do that in every single facet of the business, but enough to know what that job entails. That's how I see it, at least.
Yeah, I agree. And I think one of the challenges in this business is obviously for certain skills you have to pay, right? So if you want to find someone who's, for example, a really good machinist, or someone who's a high level accountant or a financial analyst, those people who typically are really good, in the business world, they can demand a lot of money. In this business, especially in the beginning, it was so difficult to find good people for what we're able to afford. And that was the hard part, right? Like finding a really top-notch fabricator, you could if your budget, if you have $150,000 to spend, right? But when you don't have that money, how do you find someone good, right? Because, and I've gone through it where I've hired people, they've worked here, they've gotten really good, and then good for them. I never try to hold anyone back. And they've gotten jobs, working in aerospace or medical welding or doing, even union work, and they're making really good money. And their coworkers like, where did you learn how to weld? This is amazing. And like, oh, this is the cool stuff I did. But this industry, that is a challenge with people too.
It just doesn't make sense for your particular industry.
Yeah.
So do you also find though, I mean, just coming back full circle, you started with, as you mentioned there, DSM, and I kind of find, just looking at my trajectory, which in a lot of ways my old business STM mirrored a little bit of the early days, I guess, of AMS. You're dealing with a car back then, and my clientele was probably a little different to yours. We were dealing with cars that were probably at that point 5 to 10 years old. They'd swapped hands a few times, and they were in the hands of young enthusiasts who had spent every cent and then some to purchase the vehicle. They had no money left to service it and keep it maintained. And then they'd bring it to us for tuning and modification work. And we were dealing with a Galant VR4, call it a Talon Eclipse, same, pretty much. And you'd get it in for what was supposed to be a tune. And as soon as you rolled it into the dyno cell, you're like, yeah, okay, well, this thing needs like 10 to 20 hours of workshop labor to remove all the frickin' zip ties and race tape that's literally holding the thing in pieces before I could even remotely consider putting it on the dyno. But there was no budget available to do that. So that kind of defines what you can pay a tech, because there's a limit to how much you can charge. And then what I've seen from your trajectory, and I mean, I only looking from the outside, you sort of stepped up from the Talon Eclipse to the Evo to the GT-R and now the Lambo Audi R8 market. And each step along the way, you're dealing with like a higher level of clientele. Am I sort of getting a good read on this?
Yeah, that's true. We've definitely learned, like you said, that we've gone through the same issues. We'd bring cars in that just needed a tune. You spend all this time, you put it on the dyno, get it strapped, the tuners block off time, they get in the dyno, first pull, there's no fuel pressure. And it's like, okay, well, now customer's like, oh, I paid for a tune, I get a tune, so you don't charge anything, you've wasted 2 or 3 hours of time, and now tuners have 3 hours of nothing to do because the next car's not coming in. It's terrible. So we've kind of learned, we'd pre-dyno inspections, and we've gone through all these things, and eventually got to the point where we stopped taking in cars that we didn't build because it got so bad. I'd say even today, especially today, we only work on cars that we make parts for and only cars that we've built.
Yeah, that's an interesting stance. And I mean, I've had this basically reiterated to me by a number of the high-end tuners that I've had on this podcast. Tony Palo would be another classic example who mirrors exactly what you're saying here. However, you can't start like that.
No.
You've got to build up that reputation. You've got to get the results before people know, okay, I take my car to AMS, I can guarantee I'm going to get the results. So what was that sort of journey? How long did that take, and what was the sort of process along the way?
Too long? It took too long. And I didn't have any business sense. I had a mechanical engineering degree. They don't teach you shit about business in school. I wish they really would, because that was lacking. So I was driven by passion for cars and engineering. So, we learned the hard way and probably took 4 times longer than it should. But yeah, like you said, we couldn't do that in the beginning. So we worked on whatever we can get in.
Because you got to put food on the table, right?
Yeah, and that is the hard decision to make. And you think like, we can't do this. Well, we'll piss off customers. But you have to. And yes, you'll piss some customers off.
Those probably also ultimately aren't the correct clientele for the business. And that's a bitter pill to swallow.
Yeah, it is. But like I said, it takes time to build that up, right? You have to prove yourself. You have to, people have to know they can go to you for good work. You have to have that reputation. And that does take time. And if there was a magic formula that you can say, hey, this is when you can make those transitions, that'd be great. But if you do it too early, you can snuff it out. You'll kill the business. But then if you take too long, the whole thing takes so long to grow and unravel. But that's exactly right. You have to make that transition, and it does take a long time.
If you're a fan of the podcast and you're interested in topics like engine tuning, automotive wiring, performance engine building, 3D modeling in CAD, or anything else in the high performance industry, I have something that you might be interested in. Introducing the High Performance Academy VIP package. This package of courses gives you lifetime access to all of HPA's online training for one price. These courses cover everything from tuning and reflashing petrol and diesel engines through to motorsport wiring, engine building, fabrication, design, car setup, and plenty more. Right now, you can get $500 off High Performance Academy's VIP package using the code PODCAST500 at checkout. Becoming a VIP means you'll never pay for another course again. You'll get instant access to all 40 plus courses we currently offer, plus every new course we ever release in the future. Want to define maps or tune with WinOLS? Curious about CAN bus devices or how CAD can help make your dream build a reality? These in-depth topics, as well as many others, each have their own dedicated course that are going to help you master whatever it is you want to learn. And as a VIP member, you're not just getting the courses, you'll also join HPA's online community with lifetime access to our member forums and members' webinar lessons. Again, the code is podcast500 for that $500 discount. Just head over to hpacademy.com to check out the full VIP package and everything it contains. All right, let's get back to the episode. So I see your kind of natural trajectory here was from the Talon Eclipse DSM days. Obviously, the US ended up embracing the Mitsubishi Evo platform. I think you started with the 8, was it? Or did you get the 7 as well?
No, we got the Evo 8.
So 8, 9, 10.
Yeah.
So I think we in New Zealand and Australia probably had a bit of a head start, given we've got no local manufacturing base. So, I mean, we basically had free access to every JDM model, starting with the Galant VR4, then Evo 1, 2, 3, 4, the 4 being a complete disaster, then 5, 6, 7, 8, 9. And what did you see that change from Talon Eclipse to Evo 8/Evo 9 look like for you?
Obviously, there's a lot of similarities mechanically, but like you said, the clientele, it was a new car. The people who were buying that car, they had more money to spend. And, for us, we learned a lot, and we definitely, built our reputation with the Galant VR4, the DSMs. But I think the Evo is really the first platform for us that really hit it big. And, we put a ton of work into that car. We built a car for drag racing. We actually used that same car. We converted it to time attack, and then eventually built a time attack car instead of trying to do two things at once.
Yeah. If you're going to try and do both, like just all you're going to do is compromise both.
Yeah, we're like transitioning. So we take stuff off the car, do this, and it's like, this is stupid.
No one wants to be swapping a turbo for one weekend and swapping it back for another.
No, yeah, suspension, all stuff. So yeah, but that car was, it did great things for us. We spent a lot of time. I think when we first got that car, it was a DSM shootout. I don't know if it's called the DSM Evo shootout at that point in Ohio. And we got the car. We didn't have it very long. I think some basic tuning came out for it. I forgot what it was even called. And I stayed up me and one of the fabricators stayed up 3 days in a row building some turbo kit, trying to hobble some turbo on there with a header and all this stuff. And we got it working barely. And then we drove it to Ohio on no sleep. That was stupid, but that was kind of, it was like you're driving a pure passion at that point, trying to make cool stuff for it.
You do what you got to do.
And one of the things why we were making our own parts. Well, one, I wanted to, create, innovate, make my own products. But, when I was wrenching on the DSMs, a lot of it was using other people's parts. And that was a terrible experience because customers bring in other people's parts, or you buy someone else's parts and you go to put it on, this shit doesn't fit. None of these holes line up. I have to cut this, re-weld this, grind this. So it's why did it take 8 hours to put this on? It should only take 2. Well, no, it would if it fit, but it didn't fit.
I think that's the other thing, though, that separates the likes of a company like yours, AMS, from the hundreds of other companies across the US and the world that will modify an Evo. You've got your own parts that are engineered to work together, and no one else has access to them. So that is why people will bring a car to you, because you've got an engineered solution which is going to give you a guaranteed result. It does fit, it does work. There's not some weird shit where you can't get to the bolts that hold the exhaust manifold onto the head because no one's thought that shit through. And that is way more common than I'd like to admit. But it's just those small things that, and I mean, unfortunately, the owners often, if they're not wrenching on the cars themselves, they'll just never get to see that level of frustration.
Yeah, that's completely true. Completely true. And that's what differentiated us from other companies, making our own parts. And then they worked, they fit, and they worked. And back then, like you said, people were sending the cars to us to build. We really didn't have a distribution network. We didn't have no effing idea about costs and bill of materials. We just kind of built it and sold it. Like, oh, we made we made $100 on this, made $300 on that. Like, and you really like, oh, we're making some money, maybe not, and
you don't really know.
Yeah, at that point, you're just kind of running and gunning. Again, no one had really any background as far as, hey, let's. There's a proper way to do this. Like, there's a what's margin mean back then? We had no idea. It was just
give us a sense at this point in time of the scale of the business. How many staff are we talking here?
So we're roughly around 50 people.
Oh, even back at that point.
Back then. Oh no, back then it was probably, we were doing the Evo, working the Evo, maybe 10 people roughly.
Yeah, okay.
Roughly 10 to 12. Not too soon after the Evo, the GTR landed. So I think back then, but roughly between I'd say somewhere in the teens.
But before we move on from the Evo to the natural progression onto the R35 GTR platform, I'd be remiss to not add in here that we beat you. You held the world record, I think, at the time on the quarter mile with the Evo. With if I want to remember, I think it was like an 8.42.
Yeah, that's something. Yeah.
And I had my own Evo 3, which was irrelevant because you guys never had them, and that went 8.2 at 180 mile an hour. But it's not comparable. No one really cared. So we had a customer, fortunately, who was pretty well funded, who came to us with an Evo 9, and he said to me at the time, I want to beat AMS. And we're like, well, shit, we don't even have a clue what's necessary to do that. But hey, we're up for a challenge. And I think, to be fair, you guys had probably pretty much given up on that platform at the time. You transferred to GTR. So, let's call it a hollow victory, but I'm going to call it what it was. And we did. We got that thing down to an 8.34 at 169.7 mile an hour. And god damn, that was a learning curve. I distinctly remember with that thing, every single time we took it to a drag meet, we'd do 8-10 pulls. The thing was, it wasn't making crazy power. We ran it on Q16 so that on paper, to keep the internet warriors happy, we were comparable, because I think you guys were running on a pump gas. So we were on VP Racing C16 or Q16, and it made 1,001 wheel horsepower, 42 psi of boost on a GT4202. So like all old school technology now.
Yeah.
And it ran that time. But every 10 passes, we'd have to pull the transfer case apart, and the crown wheel would crack through the base of every single tooth.
Yeah.
And we'd just replace it. So that was fine. And it's one of those things you never really knew, like, is this going to do 11 passes, or is it going to do 25 or maybe 50? And I remember one particular drag meet we'd taken it to, and he got one launch in, and then the thing got rained out. So that was all on a brand new transfer case.
Yeah.
And we pulled that thing apart just for an inspection, and sure enough, it had cracked through the base of every tooth again. So we're like, what do you even do with this information? What do you do? Because it obviously gets really expensive when it actually does launch itself in grenade.
Just close your eyes, put it back in.
Yeah. Sometimes crack testing is kind of, it's a blessing and a curse.
Mm-hmm.
So sorry, I just had to rub that in there, Martin.
Yeah, thanks. No, good. Nice job. Yeah, It's a lot of effort to get the car to go back, fast back then. Manual trans with a clutch, and it was just, yeah, it was.
I mean, obviously, that whole Evo drag racing world record has moved on. I mean, we talk about low eights now, and it's nothing. Street cars are doing that shit, but not back then.
Yeah. Well, even like standalones, they've come so far. Back then, there was no really launch control, and like what the stuff you can do with Motec today, or any really good standalone, even a launch control is. I mean, that makes a world of difference. So,
well, let's talk about your sort of learning curve with the tuning, because as I see it, you kind of had your hand in every facet of the business, like we were talking earlier. So, how did you kind of develop your skills with EFI tuning?
Just on the job, with my own vehicle. Back then, I mean, there was no really, there's no internet per se to learn all this stuff. So it was reading books.
There was forums, but as we all know, the forums, it's kind of filtering through the fact from bullshit. That's just so hard, particularly when you don't know what you don't know.
Yeah, it was learning all on my own. It was reading books about it, taking my time, understanding how everything worked, like what's, from fueling to ignition time to detonation. I mean, back then, even getting a wideband lambda was not an easy feat. You had to go to a dyno.
No.
I remember, so it wasn't like you can get let me get a wideband for $250. It was,
that didn't exist.
Oh yeah, so even getting that was a huge feat in itself, and then using that. So it was all just learning. I guess the lucky part for me, I think a good tuner, you can't just know the software. You have to know the hardware. You've had to have an engine apart. You've had to have played with cam timing on the engine. You've had to see how stuff breaks, how stuff works, understand it all. I think when those two things, when you understand the mechanical, concepts and how everything works in the engine, and you understand the tuning, that really does make a big difference. So it was really just learning that, is tuning. How do I make more power? But also I didn't have the money to break stuff. So I had to learn as much as possible before I made changes. And then you make changes, you analyze. I'm always about data too. So how do we gather what information, what sensors, what can we look at to see if I'm going in the right direction or if I've gone too far. So it was pretty methodical.
On that note as well, when you're dealing with customers, which you still are, where they're trying to break world records, and I feel like my stance has always been that if you're tuning a street car where you're taking, let's go back to the Ford G63 example, you're taking a 300 horsepower base engine and you're making 500, 600, 700 horsepower. These days, that recipe is just set in stone. Like it's not hard. Anyone can do it. And realistically, if you keep that engine away from detonation, you're running on a good quality fuel, and you've got the right parts in the engine, there is absolutely no reason why that engine should break.
Yeah.
Take that to the next level, though, and now you're at 12, 14, 1600 horsepower on the drag strip, and you're trying to beat the best in the world. Now you're walking into a somewhat unknown territory. There isn't a playbook that you can pick up and read as to how to do that. So how did you go about sort of navigating that with the customer in terms of like, hey, yeah, we can do this, but understand there is a risk that this engine is going to be a complete loss, and that's not going to be on us? How's that conversation go? And I mean, it must be the same now with the GT-Rs and, again, the R8.
It is having that upfront conversation. It's saying, hey, we have enough experience with this platform to know that, hey, with this engine, these parts in our package, this should be reliable as far as like a daily driver up to this part level. Once you start making more power, then there is a time limit on parts. And some of the customers that are really pushing limits. We have actually even like we have a waiver where we kind of, the tuners go to a certain level of the vehicle, and then the customer's like, hey, I want more power. So we actually make them sign a waiver just so they understand, like, because they can on the phone, like, oh yeah, okay, good, just go push harder. And we're like, no, this is what's going to happen, right?
It's all good until it's not.
Yeah, so we'll do the best we can. We'll make sure, from a tuning perspective, we're not just like haphazardly throwing timing at it. We know, but again, there's so many other limitations in this, like stock parts. The block's still stock, the head's stock, the oiling system, the camshafts, the rocker, what are all this stuff is still stock. we're not re-engineering everything from scratch, because otherwise it would cost $1 million for an engine.
And until you find the failure point of each of those individual components, you literally just do not know where that is.
You don't know. And then even when it fails one time, it's not like, oh yeah, we know exactly what happened here. Sometimes we have to see something break 5, 6, 10 times in a row to see a pattern, go, okay, this is kind of what's happening. Let's try this, and it's an expensive process, and a lot of people don't understand it. They think, oh, these parts are on here, this thing should make this power and live. Well, no, there's still many stock components, and you're still asking so much out of an engine, and you have to understand there is a life limit to that. It's not just, go drive for the next 20,000 miles and beat the hell out of it and rev it and two-step it and launch control and all this stuff. I mean, there's a limit to it. That's why OEMs have warranties. That's, and they're explicit if you abuse the car, they'll void it. It's funny that we've had some interesting customers, like they wanted warranties. I'm like, we're making triple the power of the stock engine and drivetrain. Like what? Yeah.
I think that stuff's almost getting easier though. And I would have almost thought now, obviously you move to billet blocks and other things, which we'll get into, but I've almost found that in a lot of ways, some of the OE engine blocks and even transmissions to a degree have almost become more and more over-engineered, which I struggle to see with the technology they have available, why the safety factor they build in is so high. And just to add a little anecdote back from my Ford G63 days, and this was fortunately something I found on my own vehicle. I'm sure you would have seen it back in your Ford G63 days. For those who aren't aware of that engine, it runs a cast full girdle as opposed to individual bearing caps for the main bearings. And what we would always see on a teardown is that was fretting between the mating surface of the girdle and the block. Yeah. And at the time, I mean, the best we had available was it's a 10 mil ARP 2000 stud. Like that was the best that was available. Yeah. And it didn't necessarily do any damage, but over the course of the life expectancy of the block, that fretting just gets worse and worse, and it's not going to be something that's sustainable long term. So I had this brilliant idea of machining out those original studs and replacing them with an ARP 7/16, which is essentially in metric about 1 millimeter larger in diameter. And that doesn't work, as it turns out. And I found that out about the 330 foot mark, or maybe the 660 foot mark down the drag strip, and I had an oil pressure warning light come on. And of course, as usual, because I'm a drag racer, the oil pressure warning light came on, but the thing's still pulling like crazy. So I'm on a pass. I'm beating the guy in the other lane. I'm staying in the throttle. It does not matter. And that worked really well until about the 1,000 foot mark, when it didn't anymore. And I lost all power. And I was in the shutdown area. The engine's actually still running, but it's making some pretty ugly sounds. So we drag it back to the pits and try and figure out what's happened. And you jack it up, and it had a custom dry sump, fabricated sump, and you could kind of see a witness mark where something's tried to come out from the inside. And long story short, we pulled this thing apart, and it had literally split the block right through the main bearing cap. Obviously, what we'd done is we'd added strength with the larger fasteners, but at the same time, we'd removed strength because we'd machined it out, and everything just failed. Yeah. And it had cracked through the balance shaft. We don't run balance shafts in those engines. It had cracked through the balance shaft, and one of the bearings that we used to block the balance shaft oil feed had just fallen out, got munched up by the crankshaft, and that was the witness mark. So, these are the hard-won lessons that no one's really telling you about, except for now I'm telling you about it. For those listening, don't put 7/16 main studs in your Ford G63. Maybe go to ARP Custom Age 625 Plus. That didn't exist back then.
Yeah, there's I could write a book on those lessons like you just mentioned. Like we can talk about an hour later, but like the GTR. Oh my God, that engine, to get that engine to hold, and where we started and where we wound up was a journey, man. Of those kind of. Hey, let's try this. That doesn't work. You made it work. This better, but this worse. And yeah.
Let's talk about that transition from the Ford G63 to the R35 GTR. I mean, there's plenty of them here in New Zealand, but their uptake for the drag racing here definitely was nothing like what we saw in New Zealand. Am I right in assuming here you're sort of seeing like without trying to sound disrespectful, a higher class of customer with more disposable income to pour into modifying their GTRs compared to the Evo?
Yeah, I mean, yeah, the stigma or that vehicle absolutely attracted customers that had more disposable income, and that there brings about, hey, they want to go faster, and that kind of opens up the door for the resources needed to develop that, because we try not to do R&D on customers' cars, but at some point, someone's got to pay for it, right? It's either the customer is the tip of the spear and understands that, or we are doing it on our own, but that's got to get spread across, the parts or the engine. So people go, why is it so expensive? Well, because we spent $300,000-$400,000 learning these lessons. So I got to get that back somehow. So yeah.
To come back one step, at that time that the R35 GTR market was coming online worldwide, how was it that you looked at that's the next direction for AMS to take? There would have obviously been other products out there, maybe some European vehicles, maybe Porsche 911, etc. Why was it the R35 that piqued your interest?
I mean, one, turbocharged. I loved anything turbocharged, the potential you could have with a turbocharged engine. And we had a good experience with Mitsubishi and, Japanese cars. I kind of like that challenge of small displacement engine, well engineered. What could we do with it? And, like the Evo, we didn't have it. We weren't able to get an Evo here until the Evo 8. And same with the GTR. That was kind of the next, hey, now it's going to be, available in the US. So it's kind of a natural next step. And because we've kind of already had that reputation maybe with the Japanese cars, small displacement turbocharged stuff, I think maybe that was also part of it. Like instead of us jumping to a Corvette or something along those lines.
So that USDM, that side of things, that really never even sort of came across your sort of mindset as an option?
No, I mean, we did dabble in some other platforms, but that was really for us, it's kind of the next natural thing was the GTR. Yeah.
So what did that learning curve look like? Because there were a few of you who were at that cutting edge of developing it, being the first in the 10s, the 9s, the 8s, the 7s, the 6s, etc. Did you find that having that competition sped up the development process rather than if you were just on your own doing your own thing?
Yes, for sure. 100%. And that was a good thing. I would say it was a really good thing until we got to the race to the sixes, and that's a whole separate thing we could talk about, because we probably could have cured some all the shops chasing sixes, pulled all the money together they put in these vehicles. They could have solved some real world problems probably. The competition definitely was a good thing and made us innovate and stay one step ahead. And hey, someone's getting close. We got to keep innovating, keep trying to, improve the turbo kit. How do we get this working? How to get the fuel system? Whatever it was, the next best thing. It was always driving us to do that for sure.
I think that stock placement turbocharger, that must also be a limitation. Obviously, with anything GTR now that is really serious big power, you've got front-mounted turbochargers, but as I understand it, there is a class now for stock location turbochargers. So what engineering challenges did that come up with in terms of engineering a sizable turbo that's still going to fit within the realms of the chassis rails and the block?
I mean, that's evolved over time because originally that's what you had to work with. So, we do the typical hybrid stuff. You took it was a turbo fold, so turbine housing and manifold all as one piece. And we found someone to machine them out, modify them to put larger, exhaust wheels, larger center cartridge in there. And that's kind of where that started. But there's limitations to that. When you're working with, stock turbine housings, you have to machine them out. There's limitations to how much power you make. So then it became into, to making a header And how do you make all that fit? That's really the challenge. And these days, to where it's gone in stock locations, it's kind of, I would say it's not streetable. You're trying to shove a turbo that doesn't belong there. So you're cutting frame rails. You're doing really, I'd say, stupid stuff. Now it's purely a race car.
Yeah, you're fitting a square peg in a round hole.
Yeah, it doesn't belong there, and it's so difficult to make it fit in there, and there's a lot of work required to make it a stock location. It's a lot of challenges. It's not something. Once I got to that point, I kind of stopped. Really, let's make a viable kit out of it, because like if we do something, if we make a product, it's not just kind of. It's got to go through proper channels. It means we have to have good instructions. It's got to fit. It has to be repeatable. The quality, all this stuff has to go into it. So the resources to make a product like that and then to sell 10 of them a year doesn't make sense. So all that stuff was kind of, once it got to that point where people are shoving, these massive turbochargers in that stock location, then it was kind of just, okay, we'll do some, but really just for some clientele here, one off, just kind of show what we can do, but we're not really chasing that.
As I see it, like that drag world is a marketing tool, and everyone wants to see who's gone fastest on the drag strip. But I mean, I've owned drag cars that don't make full power until 7,000 RPM, and you'd probably get dusted by a stock Hyundai Excel on the motorway, the freeway. So I'm interested, just from your perspective, if you're building a fast all-round street car, and road race and drag racing, just they're not even on the agenda, where's the sweet spot for an R35?
Probably around 1,200 horsepower. You can get
it's not even ridiculous at all. Okay, so 1,200 horsepower is actually a streetable combination.
Well, it is, because the size. I mean, 1,200 horsepower, which is like, I don't know, 1,100 at the wheels, but you can get a turbo in there, like the Garrett G25 series turbo, which actually spool reasonably well. Two of those in the stock location, we engineered and had a cast. It's a two-part manifold. It's a manifold and a separate turbine housing, and it uses I say a Garrett G25, and it spools reasonably well on the street, and it'll make 1,100 horsepower.
What sort of turbo response in terms of boost threshold, or spool as people will call it, would you be giving away over a stock off the showroom floor R35 with that combination?
Oh man, it's been so long since I think to give you exact numbers.
You can ballpark it.
Oh, I mean, you're probably talking, let's say close to 1,000 RPM, maybe 800 RPM, somewhere in there. We do have a one size smaller, which is good for about 900 wheel horsepower, which really gives up maybe 500 RPM over stock.
That's a pretty good compromise.
Yeah, it does really work well. For me, like a street car, I'd rather keep it a little more conservative and have it more responsive and fun than something where I can make another 200 horsepower, but it kills the low end, kills the fun.
I've kind of gone full circle in my own journey, and I think the internet really is responsible for a lot of evils here, because every car YouTube video, or back in the days of magazines, if you didn't have an Evo 8, Evo 9 with 1,000 wheel horsepower, then you're nobody. So I think what that's done, therefore, is driven the current generation of up-and-coming enthusiasts like, well, that's the holy grail, that's the number. And it's not until you've actually lived with a car like that you realize, like, I mean, yeah, get it up at 6,000-7,000 RPM, and that thing is going to be rapid. But as a daily driver, I'm going to prefer an Evo, and we're building this at the moment with an Evo 9 with the 2.2 litre stroker kit. I've toyed with turbo sizing. The engine's built to handle 1,000 horse.
Yeah.
And I've pulled it back, and all I want is something that'll make 600 to the tyre, and that's going to be a more fun package on the street. Yeah, hey, it's going to be slower on the drag strip, but I don't care. I don't even have a local drag strip anymore. So I think it's really important to actually, rather than go for those glory numbers, have a really hard think about, what do I actually want to achieve from this vehicle, and what is going to give me the most smiles per gallon.
Yeah, no, I agree. And it's the one thing too, like when we talk to a customer, and us building cars is now pretty small portion of business. I'd say it's maybe it's under 20% of our business.
So hard parts are the bigger.
Oh yeah, 100% hard parts for us is making product and selling it. That's where our revenue comes from. But we talk to customers. We definitely don't talk to them, They definitely like, oh, we got to make 2,000 horsepower. We got to make 3,000.
I think the sad fact of that is you can't tell someone until they've experienced it, though.
Yeah.
You can try and explain it,
Yeah.
and they're still going to want 2,000 horsepower or whatever that may be.
Like you said, because the internet and social media make it seem easy, and people like, oh, you don't have, yeah, everyone's making 2,000 horsepower or whatever it is, and it's kind of like back in the day when people were claiming all these power numbers on pump gas. Like, you're an idiot. Like, yeah, could you make that? Sure, but repeatable, everything's got to be right. The weather's got to be right. You got to get the right gas from the right gas station, and on one pull it'll make that power, on the dyno. But
the glory runs on the dyno have never really been what I've been about. It has to be repeatable, and also a lot of it comes down to, even, how would I put it, drag racing versus road race. They're so different. And then if you take road race to its extremes, and instead of a 15-minute, like 7-8 lap race, and now you're taking it to a 3-6 12-hour enduro, these are all very, very different targets, and the tuning is also going to be very, very different.
Mm-hmm. Yeah, no, I agree. And drag race is really pushing stuff to the edge. We did time attack with an Evo 8, and we got time attack an Evo 10, and that was, again, it's very different. It's like from the parts you select, right, from like response of the engine and turbocharger to how you tune it. It's got another 150, 200 horsepower left in it, but it's not a good idea, right? If you even like with time attack, you got to run 3-4 laps. Yeah, you could make it, but there's a good chance you're gonna break. So
even if we look at what I would consider, at least on this side of the world, the kind of the upper echelon of time attack racing, which is World Time Attack Challenge and Eastern Creek Sydney Motorsport Park, and those cars cannot do, for a variety of reasons, they cannot do back-to-back flying laps. Now, to be fair, part of that might be engine tune. The other part is actually holding the tyre together. Back when they were on the control tyre, particularly before they went to slicks, it was a case of nursing the thing on the outlap, trying to manage the energy that you're putting into the tyre, hitting it hard for the beginning of the flying lap, and then 2/3 of the way through the flying lap, the tyre's just toast, and then they're just trying to nurse it through. And then we're starting to see delaminations, because these things are making stupid amounts of downforce as well. So it's just like, it's a different thing, but I do feel like those enthusiasts who are just on the edge of their knowledge don't really understand the nuances that come into how you tune for different disciplines. And it's so critical, obviously.
Yeah, no, I agree. That's until you do it or have been part of it, you really don't understand. You don't.
No. Coming back to the R35 platform, I just want to talk a little bit about the engine itself, because obviously you get to a point where that becomes the limiting factor. And then if you want to add capacity and go for 4.1 litre or whatever, that's not maybe necessarily as easy to do with a stock cast block. And if my memory serves correct, you've actually gone about and made your own billet block. So can we talk a little bit about how that project came about?
Sure, yeah. So the stock block worked pretty well. We're making 1,000+ horsepower on the factory block with no sleeves, nothing. And then I don't know if we actually broke something, or if it was kind of the notion of, well, bigger is better.
Of course it is.
And so
I guess as well, like when you start moving up to these larger and larger turbochargers to support more and more power, then it's not a case of bigger is better with the capacity of the engine. It also becomes like almost a necessity to get these things to actually spool on the line.
Yeah. So, we're like, hey, we should probably sleeve these things, because if we start making more torque, more power, more torque, more cylinder pressure, we're going to have issues. And you'd see some like delamination, because that was, a spray-on liner on the GTR. And you see some delamination. So I think it was Darton came out with MID sleeves. So we put these sleeves in, and that process, you'll see where I'm going real quick here. You machine out everything, and you put these sleeves in, and then, you start making some torque, and this thing, pushes coolant. Take it apart, and the sleeve sank.
Yeah, how about that?
Well, we started looking into it, like, oh shit, the sleeves are not sinking. The block's pulling up around the sleeves. Well, yeah, you got rid of all the parent material and it started pulling up, around the sleeves. And so
you fixed one problem and then created another knock-on problem.
yeah, so we actually put this thing in a bandsaw and we sectioned the block, cut it into pieces. We looked at everything. And actually I found there's where the head studs or the head bolts or head studs went in, there's actually a parting line in the casting, because this was not a die cast, it's a sand cast block. So like some of the Nissan engines we saw were die cast. This is actually a sand cast block. I'm just imagine because it's lower volume.
I assume sandcast would be an inferior quality product versus diecast these days.
Yeah, it would be typically. So I found like there's a parting line right at the base of where the bottom of the head stud was, and actually you can see in some of the blocks there's like some inclusion. So the parting line of the mold, some sand would get in there, and it was actually like a weak point. So that was like a stress riser right there, and that the blocks would actually crack there also. So we started doing like making going deeper into the block, making longer head studs. We eventually moved away from those sleeves, but it's because then you just killed so much parent material that you weaken everything. So we started doing a thin wall dry sleeve and these extended studs, and the engines would support more cylinder pressure, more torque, more horsepower.
That would also, I'm just going out on a limb here, that's still going to limit the bore that you can go to, correct? If you're going to go bigger capacity, sure, you could fit a stroke or crank, but the bore is still limited by those dry sleeves.
Yeah, and you're kind of limited to a 4.1 liter at that point with the stroker and the stock bore. The heads were another issue. So I think at this point we're probably making like back then like 1600 horsepower on the factory block, and pushing. There's always one part of the head which would push. Is the chamber. We figured out the chamber is kind of flexing. There's like we call it the pork chop area. This little like coolant passage. And there was not much support there for the chamber, and the chamber would flex away. So we tried doing everything from like machining inserts and pushing it in, to someone said, oh, you got a machinist like, oh, we'll weld it and support it. Well, yeah, when you weld it, you heat everything up. It made things worse. And finally, we figured out, we literally came from the backside of the chamber. We machined a passageway from the top of the head. We machined a little flat on the chamber and had a set screw, a big giant set screw, and put like preload on it. And that fixed everything.
Wow.
We're like the first ones to figure that out. And we had the edge, and no one else figured it out until someone, of course, got our engine. And then all of a sudden, these other people had the same solution.
Oh, yeah. Off to the races.
Yeah, which is fine. It's.
I mean, these things only remain secret for so long, of course.
Exactly. So it was a long road figuring all this stuff out. And eventually, I think we're making probably close to 2,000. And it's probably, over 1,500 horsepower for sure. We're like, we're going to have to go to a billet block.
And at this point, so to give us a bit of a line in the sand, at that sort of power, 1,600 plus horse, what are we talking in terms of ET and mile an hour at this stage? And I guess also at the same time, where did that have you in the world GTR pecking order?
I mean, we had the fat, we called it Omega, which is kind of our shop car, which we pushed. I mean, we're probably at that point, we're into sevens at that point on the factory block. We've always held the record at that point, but we still, like, people were chasing, right? They're trying to go faster. So
of course, I'm guessing also at that point, your stock block has a pretty limited life cycle when you're running 7-second passes.
Yeah, 100%. And so making a billet block in itself was a journey. We approached a company in Michigan, which, they said they'd make a billet block for us. We brought them all a block, stock parts. We worked with them, went through many revisions, and again, so many issues. Thing was overheating, all this stuff, and finally, like, they were not producing. The issues we had with them was like, we suggested changes, they wouldn't do them, and they were kind of got to the point they're reluctant to kind of work together. And then we found out they tried backdooring this block to other people.
Oh, shit.
Yeah, we're done with you. We spent all this time and effort in our money, R&Ding and testing this thing.
And someone else is benefiting from your research and development.
Yeah, so this, and of course in the beginning, lesson learned, like, hey, can we sign it? We want to sign an NDA with you guys. So like that, and like, oh no, we don't do lawyers and all this stuff. And that should be my first warning to walk away. So
Yeah, that's a red flag.
yeah, so they tried backdooring and selling to people, and it never worked. As though funny, some people bought them and it never worked. So we found another company actually close to us, local to us, that we worked together, and we've had many iterations, but they got it. It worked, and we've evolved over the years. We're probably on revision 5 or 6 of the build block with many changes, and just kind of trying to make it better. But that was an expensive journey. I remember one time we also tried to make billet heads, which was about $100,000 lesson of what not to do. But I do remember actually having our billet block. We put a car together. Sorry, built an engine. We rented an engine dyno up in Wisconsin. We built a billet block, did all this stuff, censored it up so we can put it on a standalone. Sent it up to Wisconsin. We put it on this company's engine dyno, and they're running the dyno. First pull just destroys the motor. They forgot to close some valve, and the thing wasn't getting coolant, and it just melted the whole thing down. So literally just spent. I was like,
cheap experiment, obviously.
I just wanted to quit at that point. I'm like, oh, this is terrible. And they're like, oh, sorry.
Sorry doesn't really cut it. Cut us a check. That'll probably help.
Yeah, and that's my experience in this industry. Is a lot of outside service in general. If they screwed up, they're like, sorry, and they're like, this cost me $30,000. What do you mean, sorry?
That's one thing I've actually always found in this industry. Maybe present company notwithstanding, you find so many companies out there who it's a one-way street. They're more than happy to take the money off the customer, but as soon as something goes wrong where they're at fault and there's no real argument about it, they walk away and wash their hands of it. And I think to a degree, that's also what gives our industry just such a checkered reputation. I mean, there are obviously solid players out there. Yourself, there's a number of them, but you're far and away outnumbered by companies who are more than happy to take the money, and when things go wrong, they just look the other way, and that's just so frustrating for me.
Yeah, it is. It's pretty rampant, and I don't. At one point, we started looking into like how much warranty work we've covered, and I wanted to throw up because if it's on us, if we did something wrong in assembly, if it's a labor thing, we eat it. And it's been some really tough lessons. I will tell you, at one point in the V10 engine building experience, we probably had $1 million mistake, which almost ruined us. Oof. Oh yeah. So
that's a bitter pill to swallow.
Oh yeah, and that's kind of like when you said, we had some people running our engine department, which just they didn't know any better, and we ruined 4 blocks, probably 5 blocks, and put us behind a year. I mean, so not only that cost me out of pocket on these vehicles probably $300,000-$400,000, but then the lost business, the reputation. People talk. That was $1 million mistake.
Of course. It's the intangibles that just stack up.
And you know what it came down to? Torque procedure on a head stud. A torque procedure on a head stud cost me $1 million.
Okay, expand on that.
Yeah. No, so this is actually, at this point, we had someone running our engine department we trusted, and we started doing these V10s, and I think we started using a new head stud, a CA25 ARP head stud. We're getting ready for races. We had 3 cars we're building, and we put these engines in these cars, and they start running, and all of a sudden, we run them, warm them up, idle them, we check the oil. Oh, why is the oil getting milky? Yeah, all 3 cars.
And this isn't methanol inclusion in the oil, we're talking water.
Oh, no, this is no. And why is the oil level going up by 2-3 quarts?
The oil level is going down by 2 3 quarts, and the water level is going up by the same.
Or the coolant was going. I forget. It was a disaster.
Yeah.
And we're trying to figure out what is going on. I remember we're trying to get these cars ready for a race, and the race is like a month out. And we wound up to debug it. We pulled the block out. We actually pressurized. We made block off plates and pressurized the coolant and oil passages, and we found out the block cracked, and all 3 blocks cracked. And what is going on? And then so I got involved in engines there. I'm like, let's see what's going on here. And then I kind of witnessed how some stuff was being done. maybe not with great attention to detail, but also it's like ARP says, okay, torque this stud to 120 foot-pounds. Well, that's their recommended torque for that stud so it doesn't go into yield, right?
Not necessary, meaning that that's where you need it to be for an application.
That's exactly. So, and then I saw how the torque procedures were being done, and I saw that there was, lubricant being put under the washer, and I was like, let me understand this, what's going on here. And that's really where I got involved. Fortunately, also, we caught some shenanigans happening in that thing. We actually fired everyone from the entire engine team because there's some shenanigans going on, some unethical shenanigans, theft, let's put it that way. So I was getting hurt in that way. And me and another guy basically took over the engine department and rebuilt it from scratch. And so one thing, I'm like, I have to understand this whole, this block cracked obviously is too much stress on that stud. So we bought this equipment, torque cell. So it's like a washer. They use it for, I don't know if bridges or whatever else it's used for, where they have to monitor the clamp load over time. So it's hooked up to a network and it monitors clamp load over time to see if something's happening, if the clamp load is going down. So we started actually, instead of, all torque tells you is the resistance to turning, right?
Which is inferring stretch as well, indirectly.
Yeah, if you get to that point, right? If you get to the point where you're getting stretched, you're at the yield of the hardware, but you have no idea what the clamp load is. So that was a whole thing where I came up with a process. We built a rig, took the factory bolts in this this load cell, and measured how much clamp load there were. And one thing we learned is factory. Like a lot of people will say, oh, you got to get rid of factory hardware and get ARP or whatever race hardware. Some factory shit is really good. Torque to yield hardware is incredibly, I'd say, repeatable. So I tested, it went through like 20 factory head bolts that are all torque to yield, so you torque it to a certain value, then you turn it, degrees.
So just for those who are maybe not picking up what we're putting down here, a lot of factory head bolts like this, the torque to yield, as you say, you're actually torquing the fastener beyond its yield point, so it's deformed and you cannot reuse it.
Correct. It's deformed and it's living in this area where it's
what's it called? Plastic deformation?
Yeah. So you're living in this area where no matter if it heats up, expands, the clamp load stays consistent. And obviously, if you go past, there's like a range, right? And this material is engineered to live in that area, right?
Vaguely recalling a university paper on this, but there was a few haircuts back.
Yeah. But it's good and very repeatable stuff. So when I took that ARP hardware, the C825 plus or 625 plus hardware, and I torqued it to 120 foot-pounds. I mean, we were getting I think the factory stuff was like 12 or 13,000 pounds of clamp load, and we're at like 19 or 20,000 pounds of clamp load. So way higher, than OEM. But then also I found inconsistencies. So I played around with where you apply the lube. If the washer spin, I mean, I learned so much about just torquing and fasteners at that point. And I spent probably a week coming up with a process where I can set up a torque procedure where I can get the clamp load very consistent. And things you don't think about, if you reuse the same stud, for example, or fastener over and over again, the threads burnish. And now if you torque it to the same torque, your clamp load actually goes up because now there's less resistance to the thread. So there's a whole bunch of things that come into play, but that was a week-long process of coming up with a torque procedure to get an increased clamp load, but that was consistent across all the studs. So
one thing, just to interrupt there, and this is sort of, again, I'm just going back to my 4G63 days. This was simpler times, and I think if I was building a high-end 4G63 drag engine these days, I think it's going to be easier for me to make more power than I ever did. But back then, the fuse was always head gasket integrity. And yeah, I played around with a few things, but we'd sort of settled on, and ultimately, I don't think now it's even close to the best option, but we were running a stainless steel O-ring that was in the block. If my memory serves correct, we were running about a 6 or 7 thou protrusion on there, and we were just mating that with an HKS stopper type head gasket. And that got us through to about 55 psi of boost, but that was kind of it. But back to the torque on the fasteners, and I think we'd gone to, it must have been like a 1/2 inch ARP stud. Custom Age 625 Plus didn't exist. I think we might have had L19 material back then. And you look at the torque spec, and you're like, this is wild. And I always wondered, because we were not on a billet block, this is all factory car stuff. None of that billet stuff existed back when I was racing. And I was sort of thinking, yeah, okay, well, sure, we're well and truly above the factory torque spec, but are we now starting to just bow the cylinder head between the studs and kind of fix one problem and create another? And I'm pretty confident that's exactly what was happening. Is that sort of hold true to your experience as well?
Yeah, it definitely does. And you'll see stuff happening in the bore. For example, you'll see the bore.
Oh, bore distortion for sure.
Bore distortion. And you'll see it sometimes in engines where the stud is. You can see where the stud boss is in the bore, and you'll see patterns of wear there. So it all comes into play. There's limitations to it all. We've gone 6s on a stock head gasket in the V10.
Right.
We've gone 690s on a completely stock head gasket. But part of that was building out that torque procedure, which got consistent clamp load across the whole cylinder head. It's not too crazy. We're not breaking stuff, but it's high enough and consistent where it was able to hold. So there's too much also. You can definitely, we've had, on GTRs, if you go too high of a clamp load on those, you'll crack the head.
Yeah.
You can definitely crack the head. Yep.
Well, in terms of head gasket sealing, regardless of the platform, it looks to me like the current go-to is still sort of the aluminium bronze sealing ring. Is that your experience as well, or are you going a different direction?
Yeah, that's what we're using. It's called the L ring. It's basically a ring that sits in the block and interfaces with the head, and you got just kind of a concentrated pressure point around the whole chamber, as opposed to like a multi-layer where when you do start compromising the gasket there, the layers start shifting and moving and walking, and it kind of, goes to hell. With this, it's not a perfect seal all the time. Once you start making a lot of cylinder pressures, you do have some seepage here and there. It does happen, but it does seal back up. It's not perfect. And we're still chasing the perfect seal when you're making, 2,200 foot-pounds of torque on a 6-cylinder, which is insane. The cylinder pressure at that torque has to be crazy, so.
I'm interested as well. Are you, I can only assume are you purposely controlling peak cylinder pressure through that peak torque area and then ramping boost and timing back in so that you're actually controlling and limiting peak cylinder pressure, but also ramping the power in higher up?
Depends on the platform. On GTR, when you're turbo limited, for example, in a class, you're giving it all you can, right?
You want everything.
Yeah, you want everything. But when you're not, obviously, you go with a bigger turbo. You go with something where you can ramp in the boost with RPM, 100%. That's what we do on the V10s, yeah, because it'd be stupid not to.
Okay, I feel like we've scratched the surface. There's so much more I want to talk about. Let's just stick to the. This probably covers the GTR and the Audi Lambo platform, the DCT. And I've been to TX2K, and you watch an R35 GTR go and do its burnout, and then it'll sort of park itself out, sort of past the 60-foot mark, and nothing will happen for a minute while the driver sort of does the old control alt delete, because you're sort of, as I understand it, still limited to maybe something like an Ecutech reflash of the DCT, despite it having every Dodson aftermarket part under the sun. Are we still battling a limitation on the understanding of these DCTs, or I'll admit that was shit. That was 2019. I was at TX2K, so there's a few things that moved on since then. Have we got full understanding of these things absolutely bulletproof?
Yeah, I think that's all been sorted out. And yeah, I remember they used to back then, you had to turn the car off, turn on, hold some of the switches, the R mode, this and that, up, down, left, right, up, down. But no, that's been all sorted out.
Yeah, hold your tongue to the side and hope.
Yeah, no, that's all been sorted out. So the transmissions and the GTRs are as far as electronic side, they're pretty good, and even hardware side. There's been Dave Rohrschneider's GTR. He's gone 6s so many times, and those stuff will still break, but it's so much better than it used to be. It really is, and part of that's a strategy too. Like, how you do your cuts on the shift, how you do launch control, how do you slip the clutch. You just drop it. You'll see sometimes GTRs launch and you'll see this hop and all this crazy porpoising, and we were there at some point and we figured stuff out, and now it's like, how do you get this thing to kind of engage smoothly? And if you transmit that power just a little bit longer and take that giant torque spike out of it and let it get in there, that it's easier on parts, it's better for the car, it's smoother.
Sure. That must be a tightrope to walk though when you're talking, even an aftermarket multi-plate wet clutch inside of those DCTs. Like the clutch material, these clutches are so thin, you want them to slip so that the tire stays hooked up, but that slip creates heat. So how do you kind of balance clutch life versus keeping the tire hooked up in 60 footing?
Yeah, you're absolutely right there. Those things are so thin, and we've been there where you slip a little too much and it warps the clutches, right? It warps the steels.
Yeah.
So you just learn from experience. You learn from experience how much you can slip it and how tight of a line you can walk, because you don't have much room to play with there. You have 10, 11, 12 clutches in there, all super thin, and you have to slip it just enough. So it is tough to figure that out. And
is that problematic as well once you're off the line? Obviously that's the big one, is 60 footing, but you've got a bunch of other shifts down the track as well. Are those ones less problematic with slip because you don't need so much? Although I'll sort of temper that with, obviously if you've got a very harsh shift, 1, 2, 2, 3, that's also in itself likely to upset the car and you're going to lose traction.
Yeah, and that's again part of the tuning strategy is how do you bring torque in and out during a shift, right? If you abruptly take it out and abruptly bring it back in,
nothing good's going to happen.
Nothing. Yeah, exactly. Nothing good's going to happen. You're going to, traction wise, parts breakage wise, clutch engagement. I mean, even the clutch, going from the one clutch to the other clutch takes some time, especially when you're drag racing a really, really fast car. The other clutch is supposed to be engaged already, but sometimes the shifts happen so fast. It's timing of everything.
Yeah, absolutely. Am I right in saying the TCU side of things, is EcuTech still the go-to for that solution?
Yeah, from everything I know, again, I haven't been part of that portion of it for a while, but as far as I know, the tuners, the EcuTech stuff still, it's got it well sorted, it all works really well.
Is there advantage down the line in terms of someone coming out with a complete standalone controller? I mean, I know at one point Motec were developing an M1. I think that thing completely stalled, and that would be probably a good decade ago now. Or have EcuTech just got it so dialed that, yeah, that's the go-to gold standard, everyone's using it, it just works, no need to look further?
Again, I'm not speaking from direct experience, but from what I know, yeah, I don't think there's a need for that at this point. I think it works well enough to where it would make sense to invest all the time. And I mean, there's so much going on in the trans. You get one thing wrong, like really bad things can happen, right? So again, having that whole building out a strategy and testing it, I think I don't know if it makes sense anymore, especially when it does work well.
Yeah. It's one of those sort of, if it isn't broken, don't fix it. I mean, along those same lines, is there any kind of advantage towards creating a conventional sequential dog engagement style 6 or 7 speed gearbox for the R35 platform that gets you completely away from DCT control, more something that we would see in conventional motorsport? Or then does it become so fickle? I mean, I know all of these drag records are so, I've got the fastest white R35 GTR with a pink gear knob, Yeah. As soon as you no longer have a DCT, no one's going to recognize that record because it isn't an R35.
Yeah, and the same thing goes for, I think what would make more sense, even though I'm not a fan of automatic transmissions, I mean, putting automatic trans in there makes a lot of sense. You've got a torque converter, you can control the slip. It's easier on all the parts, but I know people have done the automatic route. It's worked well, but I don't think anyone's done anything sequential wise.
Well, when we were seeing that was the unlock with the R32, R33, R34 platform, which I mean I consider completely separate to the R35, RB26. It's not the same car, despite maybe a little bit of the DNA passing across. But I mean, back when I worked for Heat Treatments Racing in New Zealand, who had at the time the fastest R32 GTR four-wheel drive record with a 741 or whatever the hell that happened to be. I mean, you'd watch Reese run it past in that thing, and I mean, he was just about pinballing between one wall and the other on every gear shift. And then I think it was another drag racer here in New Zealand might have paved the way with the auto conversion. All of a sudden, that's when all of the Australians started going sixes using that same combination. Do you call it a GTR? Do you not? I don't know. That's a personal thing. But I mean, you can't argue these cars go fast. Just having some experience recently, not that it would be comparable or compatible with the R35, but I mean, the control that these 8 HP automatics give, they're just walking this razor edge between what I'd consider a conventional automatic and a proper motorsport, almost sequential gearbox. They're absolutely insane, but I think we're probably getting a little bit off track here. just coming back one step to ECU control. I mean, as I see it in the R35 world, I mean, street car, you could reflash the factory ECU. There's a few options there, but once you're starting to get serious, to me, as I see it, you've got two players, which is Motec and Cyvex. Am I right? Am I missing anything there?
No, that's pretty much it. I mean, the stock ECU does get you pretty far on the GTR, and for street cars, I don't think it have features like custom maps you can do for traction control, things like that. So that does work well. But once you start making big power, there's some, with Cyvex or Motec, you can do some really cool things. I mean, obviously you can introduce GPS-based traction control, because you don't have a good ground reference with an all-wheel drive car.
No, of course not. Everything's wheel spinning.
Yeah, everything's wheel spinning. So, and I mean, like on the V10s, we use laser ride height sensors to control wheelies, honestly, because those things make enough torque and traction, it'll do a wheelie on you. So
I'm interested on that basis. We've had Obsidian Group on here as well with his an INS, initial navigation system, using gyros for wheelie control. Your opinion, that versus laser ride height?
We haven't tried the gyro or the yaw you'd use there. We haven't tried that. We do use his stuff for the GPS based ground speed reference, and it works really, really, really well. But we've just kind of stuck with the laser as far as, and it works well. It gives us a good reference, and Motec has a pretty good feedback loop in there. You still have to dial in. You can't just throw, let's say, all the torque at it and let the wheelie control. You still have to kind of have like an initial.
Yeah, common sense.
Yeah, you have to use common sense, obviously, because. And that was the fun part, where we were dialing in the wheelie control when it was still kind of early stages. We got some good pictures underneath the car, going down the track.
Yeah, normally nothing real good happens when the front wheels come back down, though.
No, I mean, the crowd loves it, but yeah.
Nothing else. The crowd aren't paying for the repair bill, though.
Yeah.
All right, let's move on. I'm guessing, kind of just like you saw that transition from the Evo platform to the R35 GTR platform, as I see it, over time, people moved on again to the Lamborghini Huracan / Audi R8 platform. Is that just a case of you're starting to deal with clientele with a little bit more money? You've got 5.2 litres, you've got 10 cylinders. It's just simply easier to make more power?
It is easier to make more power, but this car went against what we've done in the past. We always started with a car that was turbocharged. And in this case, the car starts off NA.
Does seem incredibly easy to fit a pair of turbos in a location that Lamborghini almost made available for turbos, though, right?
Yes, yeah. It's definitely, as far as like the hardware wise, I'd say you had the room there and you had the space to make it all work. It was really getting the software right. It's how do you tune this thing? How do you get the trans to play ball with everything? That was really the hard part with this thing. And tuning was before Motec was out or Cyvex was out for these things. That was you had to use the OEM Bosch ECU, which didn't have a strategy for boost control at all in there,
Hard to believe.
and it didn't have it didn't have a strategy as far as how to handle the airflow and the time. You had to really do a lot of things in that thing to work. And
Essentially, you're so far beyond what the factory ECU was envisaged to cope with that you're in no man's land.
yeah, it was a challenge. So that was
What was the sort of the gap in timing between these platforms becoming popular for turbo modification and the likes of Cyvex and Motec saying, maybe there's a gap here we need to fill?
the generation that engine. So that was, I think that was 2017 or 16 for the R8. I think 17 for the Huracan, and it probably took them, I'd say, a good 3 years, probably 4 years to.
I mean, these are complicated vehicles as well, particularly when you're starting to develop torque-based ECUs, which are so critical when you're dealing with a DCT. You can't just put a speed density platform onto the ECU, call it good, and hope that the DCT is still going to shift gears, because that's going to be a hot mess.
Yeah, the stuff they had to figure out with that, the CAN bus, for example. I mean, just, like you said, the torque-based control, it's got to listen to the trans. The trans is sending a request, right? Because it's not going to shift, or it's not, the good things are going to happen, like you said, if it doesn't listen to that. So just to figure all that out, I can't imagine the time it took. And we're part of that early development process. I remember getting a whole CAN sniffing cable from Motec, and logging the vehicle on the dyno and sending himself back and forth. And
because this isn't also a vehicle that there's like 5 parameters being transmitted via CAN. There's going to be hundreds as well, and then you've got to figure out what each of those messages actually is coming from, then decode them, figure out what the scaling is. Like this is it's maybe not rocket science, but it's also, it ain't easy.
Yeah, it's not for the average. And we thought about it, I think, when Motec, like, oh, you can do your own packages, right? Use build. And I'm like, I have no idea what I'm doing there. You need to be a software engineer. You got to, I mean, that's, decode all the CAN, and a lot of this stuff, you have to have some, I mean, if you have some factory reference, factory material, which, that's a whole other cloak and dagger game as far as OEM information. But if you have even having that information, there's still so much to know and learn to figure all this stuff out. It's pretty wild.
Yeah. I mean, I think John Reed from John Reed Racing, who we've had on the podcast before, I mean, he develops packages for underground racing, who are obviously one of the premier Lambo and Audi drag races. I mean, I think he was pretty early to market with his solution. Motec then came out with their own, and I could be speaking out of turn here. I'm pretty sure the Motec solution is definitely torque-based, and it's very integrated, as Motec normally would do. I think John Reed has come up with a simpler solution in terms of it isn't torque-based. I don't quite know how that interaction works. Hey, the cars go fast. It's obviously working, but yeah, different way of coming about that, and I can only imagine that John's put in a few hundred hours to get that package where it is.
Yeah, no, like I think the early stuff was, I think, piggyback. So they still had the stock ECUs and have a Motec on top. Now I don't know what they're using. I don't know if they're using the Motec package. Maybe, I don't know, but yeah.
So where do you sort of see the limitations on that Huracan package? And I'm being selfish here because in time, I'm going to add a couple of turbos to our Huracan. So yeah, if you're talking street level and you don't want to go billet block, and maybe you don't even want to open the engine up, and you want to retain stock DCT, be it with a flash to upgrade line pressures, etc., where can you get to in a streetable package? What sort of power levels are we talking?
So you're saying you're not opening up the trans at all. You're keeping the stock trans, right?
Let's start at that level. Nothing's getting opened. We're just literally bolting intercoolers, 2 turbos, and upgrading the fuel system.
Yeah, you're talking to roughly about 1,000 horsepower, let's say. And then you're doing things to obviously limit the torque on the trans in certain gears, or especially how the torque comes on between shifts, things like that. So we've got trans tuning pretty well sorted, and there's no Ecutech for that. That's all done through the OEM TCU, so we can increase line pressure. We can control how the clutches come in and out a little bit. But yeah, there's definitely that's definitely a weak link. The trans, the engine will take more, the trans is the weak link plus. So you can make about 1,000, but you got to still you can't go crazy. You gotta be able to control it well.
And as I understand it, first gear becomes sort of the initial weak point as well within that stock DCT. Is that correct?
Yeah, first gear, second gear, those two for sure.
Okay. All right. 1,000 horsepower is not enough to keep me happy. So we want to go up to, let's say I want 1,200. That's a nice round number, I think. What am I going to need to do to get that reliable? You can see here I'm using this podcast purely as a learning curve. So I make no apologies. I'm being selfish.
There's certain things like the clutches. You do have good clutches. The clutch basket. There's this drive gear on the clutch cover that breaks sometimes. So there's really the clutch components and clutch cover that you should start upgrading at that point. And you're still, I guess, limited.
That gear set, I'm guessing, is still kind of be a weak point too.
100%. People say, I make 1,200 and my gears. I'm like, okay, same guys I make whatever on pump gas. Like, yes, you can, but it is something you can do over and over again. It's going to be limited.
Yeah, I don't really want the thing on the end of a flatbed tow truck every sort of second weekend either. Right? So it's one of those things. So yeah, okay, good to know. But engine at that point, 1,200, that is still going to be sound if you're on a good quality fuel.
Yeah, yep, 100%.
Good to know. All right, I won't push it further. Oh, actually, no, one further point. At what point does the engine become the limiting factor in terms of, I'm not talking here billet block, I'm talking piston and rods cry enough and want to exit stage left?
We haven't reached that limit. I didn't want to.
No, that's going to be a fun limit to find.
Oh yeah, well, I've pushed it, not a V10. I've pushed another engine to the point where it ran a record pass. It still ran, but it sounded a little weird. We took it apart, and all the rods were just a little bent. That's like the perfect time to stop, obviously.
Absolutely. Don't do another pass.
Yeah, do another pass. But no, with the V10, we have not found that limit. You'll see like stock pistons will crack. If you're making a lot of cylinder pressure, you get detonation. You'll crack a piston.
I think on that note as well, when you're talking about cracking pistons, it does come down to, obviously at some point, cylinder pressure exceeds the limit of a factory cast piston, and it is what it is. More often than not, I see issues around failed pistons as tuning related problems. As you just mentioned, detonation, all bets are off at that point. Maybe the engine will last through it, but the piston is going to get hurt.
Oh yeah, and that's the tune makes a huge difference. We built an engine for someone. And we'll build engines a lot. We'll send them out, right? We built it for someone, and like, oh, something happened. We got the engine back, and pistons melted. We're like, can we get a log of this thing? And we get the log. This thing's, it wasn't making that much power, but it was detonating so hard the whole time. Like, what is happening here? Like, and no matter what parts you put in it, it's not going to live, right? If you're detonating that hard and long enough, you're going to break no matter what part you put in there.
Yeah. But I mean, running on a poor quality fuel, and again, all bets are off. All right, so let's park the sort of GTR, the Huracan. Like, how do you look at what's the next model to support? And I mean, obviously, both of those cars we've talked about, Huracan R8 maybe more so than R35 GTR. These are expensive cars to get started with. There's pros and cons with that. Obviously, you're dealing with customers generally who probably have a little bit more disposable income. So when you say to them, okay, your build's $50,000, $150,000, maybe they're not going to bat an eye at that when they've just dropped $500,000 on the car to start with. What's next in the future in terms of supported models that you've got on your radar?
So all the cars we've talked about up to this point are all what I'll call halo platforms. And many years ago, we kind of went down a different path, I'd say. So we have these cars like the GTR, like the V10, that are incredibly resource heavy, meaning it takes a lot of knowledge and a lot of money to figure this all out and how to make all this power. And you're not just making a few parts, you're making a turbo kit, now a fuel system, now an ignition system, now figure out how to build the engine, how to make, so you're going on this rabbit hole of parts and knowledge, but there's customer base to support that. So I'd say diverge where making parts for vehicles that are more bolt-on, and we've chosen other vehicles that are, you won't see them going on a drag strip, setting records or going 7 seconds. But for us as a business, like the GTR, the V10, that was cool. We do sell a lot of parts for that, but it consumes a lot of resources, and you can't do that. And I've made the mistake where people are like, oh, well, I want to do this car. Can you guys do this car for me? And I'm like, oh yeah, that sounds cool. Let's do this. And we'll kind of partner up and work with them. And like, oh shit, this is going to take a lot of resources, because people, to figure this stuff out, if I could clone my tuners, myself, my engineers, the good techs, clone a whole bunch of those people, but there's limited resources, and it takes so much time to figure this stuff out that we're only going to focus on one of those platforms at a time. And I can't tell you what's next as far as which platform we're going to take to that level where it takes the time and effort to debug all this stuff. I can't tell you, because again, it is so intensive. It takes up so much time to figure this out. It's got to have a payoff, obviously, in the end.
I guess you have to sort of figure out what the platform is going to look like in terms of uptake from the tuner market. And what I mean by that is what is going to be popular for the mainstream enthusiast, and they're going to want to modify it. But at the same time, it also has to be at that point where they are going to be prepared to throw XYZ dollars at it, because otherwise it's just not going to make sense, is it?
Yeah, no, and to give you an example, the Infiniti Q50, Q60, it's a Nissan V6 twin turbo sedan and coupe. I think we sell more parts for that than we do for the GTR.
Wow.
Because they make so many of those.
Yeah.
At the peak, they're making probably 60,000 between the coupe and the two-door. They're making over probably 80,000 vehicles a year. Whereas GTR, near the end, you're talking a couple hundred cars a year. So there's just so many more of those vehicles out there, and that's kind of what we've been focusing on is creating these packages where we have bolt-on parts that will get you another 200-300 horsepower more out of your vehicle, but the average user can enjoy it, and it's reliable, and you don't have to really worry about it. And we'll create the parts, we'll create the package, the tuning platform for it, where someone can, hey, I want an Alpha 5 or 6, I want 600-700 horsepower out of this vehicle, and it's we can repeat it and sell it. And I'll give you a quick example here. For the Subaru WRX, the VB model, which is a F824F motor, we made an intercooler for that, and I think last year we sold, I don't know, let's say 300 intercoolers for it. You know how many customer support questions we got for those?
700?
No, I don't know, a couple, right?
Oh, right, okay. So it's out the door, you never hear from them again.
Yeah, you never hear from them again. Whereas we've made a complex fuel system to support all this horsepower. Whenever you sell it, it's like the instructions are 100, I think for the GTR, 100 pages long. There's always questions, and it's just, yeah. So there's like,
so you have to balance the human resources that are going to go into tech support on a product, as opposed to just cash in the bank. Your margin on the sale of the product is actually ongoing.
Yeah. So yeah, we got to make and sell the products that are going to let us spend that money on racing, basically. So,
yeah.
Yeah.
All right. So let's sort of move this around a little bit now. So, what does AMS look like today? You kind of alluded to earlier, sort of 50 odd staff. Is that kind of where you are at the moment? Size of the facility, and I guess even just whereabouts in the US are you located?
We're outside of Chicago. We're on the west suburbs, probably an hour outside of Chicago. You go 15 minutes west of us, and it's cornfield. So it's pretty low key around here.
So you can just make your own ethanol.
Yeah, I wish. With the gas prices these days, yeah. We're in a third location now. This is about to double the space we had at the last location. We moved. Now it's going to be 3 years. We're just under 60,000 square feet at our facility. We can probably do, I don't ever want to move again.
Moving is such a time suck, not to mention the absolute cost.
Oh yeah, it's I never want to do it again. But yeah, so we could probably do, I don't know, close to triple the business we do out of this location as we're doing now. We do have room to grow. As far as people, We've got 50 people. We've got obviously room for more, but it's not about adding people. It's about what makes sense. But for us, years ago, myself and this guy Lance, who's incredibly talented and meticulous, we stepped in and kind of rebuilt our engine program from the ground up. Fundamentals from, how we clean parts to bringing our own machining in-house, all this stuff. And since then, he's taken over. He's done an amazing job, built out a team, and our warranty rate has gone down to almost nothing as far as engines go. We've got a really good program there.
So just to touch on that, you're doing all of the machine work in-house. You're not reliant on any external suppliers for boring, honing, balancing, etc.
We have our own balancing. We don't do headwork here yet. That's maybe the next thing. But yeah, as far as that, we have a CNC block machine, which is for all our common machining operations, from decking the block to boring. We have a CNC hone. We've got a balancer here. We've got all the tools, and equipment to do all the machine work ourselves. So putting our own sleeves in. As I've learned over the time, if I sell someone an engine, it doesn't matter who I had machine it. If something happens to it, I'm eating the shit sandwich, right? Because no one else is. I've dealt with places where it's like, here's a bare block, it's machined, cleaned, everything's ready to go. We put it together, send it overseas, and the customer sends us a picture of them doing oil change, and there's a spiral aluminum machined piece in the oil filter. I'm like, Jesus Christ, I'm like,
I mean, no one's infallible, obviously. My own experience through building probably 0.01% of the engines that you have through your business is that 99% of the problems that I had were always as a result of outwork. The other issue that comes along with that is you are therefore at the whim of the external supplier and what their time frame is, and that doesn't really work that well when you have a race meeting coming up in a week's time and you've got a block that needs to be bored and honed and then assembled. And I won't name names, but we were in a rush to get an SR20 block back together for an endurance race here. This is a few years ago. And the SR20 main bearing caps are hopeless. So obviously you fit a set of billet caps, and I think the ones that we had were from maybe Platinum Racing Products in Australia. I can't remember, it doesn't even matter. And it was an early version where they hadn't actually gone to the point of CNC marking the location 1, 2, 3, 4, 5. No worries, send it out for machining. It comes back. I put the bearings in, I put the crankshaft in, I put the thrust washers in, torque everything in place. I turn the engine up the other way. I rotate the crankshaft to start installing the pistons, and I hear tink tink. I'm like, that just can't be good. And there are the thrust washers on the floor, because what they had failed to notice is that the center main is actually wider than the other 4 main caps. So they'd machined the damn thing in the wrong place, and at this point it's been line honed, so I'm screwed. There's no coming back from that. And those are the sort of problems. Hey, maybe that could have happened in-house as well. Like I say, no one is infallible, but at least if I'm the one who's fucked it up, that's on me.
100%. If I mess it up, I want to learn from it and not let it happen again. But if I'm relying on someone else and I can't control it, and I'm liable for it all, I try to bring it all in-house. And don't get me wrong, we've had some good partners, but we've had a lot of hard lessons we learned along the way of what we have to really bring in-house. So, we've got a clean room. It's a separate large room with its own HVAC, and it's 73 degrees Fahrenheit, around the clock, 7 days a week in there.
That's actually something that's easy to overlook, is the controlling of the temperature, because when you're dealing with a product like I'm going to call it aluminium, you can call it aluminum, whatever, same. But obviously it has a thermal expansion coefficient. And, if you're in the middle of summer, and I'm going to talk degrees C here, let's say you're sweating your ass off and it's 35 degrees C in your engine room, that's very different to the middle of winter where there might be ice and snow on the ground, which there currently is outside now. And hey, your engine room might be a very uncomfortable 10 degrees C. And just controlling those things, controlling what you can control is so critical. I think that whole engine building side of a business is so fickle, because these engines are so expensive, yet the margins are tight. And it only takes one thing to go wrong, and all of a sudden you're completely underwater on the whole deal. And of course, you have to make it right for the customer if it's something that you've done wrong.
Yeah, I've been there again. Like I've been there. I've learned the hard lessons, and it's like we cannot afford to make that mistake again. So what do you do to avoid that? You know, it's how you learn from those mistakes. It's what to look out for, like what to be aware of when you're trying something new. For example, it is difficult. It's not a I don't know how machine shops in general. Like if you're a general machine shop just machining any engine, no thank you. That is not something I'd ever want to undertake, because like for us to even learn, and I'll go a step further and call it engine development.
Well, that is exactly what it is.
We're figuring stuff out. You know, how do you improve things? So that's like people like, oh, can you start building this engine? Like, sure, but we still have to figure out this. And then once we get into the engine, if we really want something that's we can sell the customer and be confident it's gonna hold this power level, this torque, it's gonna take time to figure out. It takes time.
Oh, and again, just some anecdotes from my past, and I mean, these are all prehistoric by current standards, but back when I was running my Ford G63 drag race program, there was the old well-known problem with the DSM crank walk situation. And a lot of people couldn't figure that out. For those who have never heard that term, crank walk is when essentially the thrust bearing inside of the engine block, which is there to support the crankshaft, when you apply clutch pressure to it, so it's trying to essentially force the crankshaft through the front of the engine block, and those thrust bearings would fail, and then over time they would fail to the point where the crankshaft's wearing against the block, and then you've essentially got a total loss. The block's ruined, the crankshaft's ruined, throw it all away and start again. And we developed over the course of probably 2 seasons a couple of solutions in terms of modifications to the bearings, and also aligning the oil gallery holes to the hole in the bearing to actually solve that problem. But I mean, that doesn't happen overnight, and you're also not just going to look at the first iteration of failure and go, oh, I can fix that. I can see all of the issues.
That's easy.
You may think that you can, but it takes time, and you have to actually prove that works. And just like it sounds like you guys do, I don't want to be kind of using my customers as guinea pigs. I wanted to solve that in-house and make sure that I was confident in that solution, and then we could roll that out.
Yeah.
Now, moving on, so I'm interested, what does a day in the life of Martin look like now? What's your sort of role within AMS, and what are you doing?
So I took over actually the engineering and R&D department about 2 years ago. It's like with cars. I love making cars faster. I love making parts better. And what I've learned is I just like improving things, right? I look at something, like finding the issues with it and how do I make things better. So a lot of that is like with the business, how do I make the business better? And one thing, like in the R&D department, when I came in, we're making good products, but it's taking a very long time to make them. So, the goal was to cut that from, let's say, 2 to 3 years for a product to come out. Let's cut it down to 1 year. Let's bring process. So for me, it was managing a department, managing the people, but also building out a process so we can, make products in a quick, efficient manner right the first time. So a typical day for me now it used to be, it's still pretty hectic, but we've got anywhere from 25 to 30 projects in engineering going at one time. So
it's a lot.
Yeah, it's a lot. And we had to implement a project management software, and we customized it, put a lot of automation into it. We're using AI for a lot of things too. But, we've got Toyota products, we've got Ford products in development, we've got some Subaru stuff in development, we've got more V10 stuff coming out. So we've got, a lot of things happening at once in an engineering team where they're scanning, they're designing. We have a joke. We do have a lot of meetings here, but it's a lot of touch points. There are a lot of quick touch points of when we create a product, is working with our sales and marketing team, make sure what we're coming up with is viable product, what's what the customer is going to want. We're looking at manufacturing risks. We're looking at, we have a department that test fits our products, make sure that the 3D prints or samples fit correctly. We get feedback from that. So it's a lot of just kind of guiding the path of, getting a product from start to finish. That is, a lot of my time. I'm still involved in a lot of like development and product testing. So, just today I was on our Subaru WRX. We're testing bolt-on turbo. So we have a Motec dash that basically travels from car to car. It goes at you onto our flow bench also. We just load up different calibrations. So on the flow bench, it's, measuring a mass airflow sensor, pressure drops. We pull it out, goes in the Subaru. I built a whole configuration for all the sensors we put in the Subaru. So we're doing product testing for a Subaru or the Raptor or whatever. We can still just move the dash from vehicle to vehicle. So I built all that out. But, I was tuning on the dyno this morning, testing turbos on the Subaru. So my day's a mix of things. So it's from project management to actually doing some of the testing myself.
Just looking at your face and listening to how you've explained that, it would seem to me that you're every bit as passionate now as perhaps you were when you started the company. Is that true? I mean, I'm sure just like any business, not every day's sort of sunshine and unicorns, but still passionate.
I am. It's different. It's more focused. I'd say before I was, it was more driven about making the car as fast as possible at whatever cost, making the product the best possible at whatever cost. And it's much more focused, which, I'd say sometimes it takes the fun out of it a little bit, but there's still a ton of passion, how to make the product better, but how do we still make money, without getting out of control?
Yeah, I guess that must be a tough one where, I think probably my mindset would be similar to you. What I want to do is just make the best, irrespective of everything else. But there's also no point making a $20,000 widget when the market will accept $1,000.
Oh, so I'll tell you a really funny story here. So this is years ago. The engineering team at that point and the engineering manager, who was an engineer who just moved up into the positioning of manager, they were making a strut tower bar for, I think, a Mercedes CLA, was it 40 AMG? Well, I forget what it's called, but the 4-cylinder turbo one. And they're making a strut tower bar. And at that point, like the engineering team wasn't communicating with sales and marketing. We just told them, we're making a strut tower bar. So I think the engineering team decided that this thing should cost $950. And then they said, our engineering manager's like, our cost should be like $600. And I remember sitting in on a meeting where they're presenting this product. Okay. Like, this thing has titanium hardware, titanium. I'm like, what the fuck? I'm like, yeah. I'm like, why? I'm like, why is this all happening? Oh, well, we're designing it, and our target bill of materials cost was $600, and we were nowhere near there. We had plenty of room left in a bomb, so we decided to use titanium. I'm like, oh my god! Like,
just because you can doesn't mean you should.
Yeah, so they were filling the bill of materials with more features when the thing, no one bought that thing. No, we couldn't sell it. We couldn't give it away. I think we wound up giving it away with some of the products because people were willing to pay maybe $400 for it, and our cost was $600. But that was some of the dumb shit we did.
But I think the old saying is you learn more from your failures than you do from your successes. So we're all guilty of exactly that as well.
I have a lot of lessons I've learned that way. A lot.
I actually just wanted to also bring back, we briefly touched on this before we started recording, but will always sit in my mind from earlier days back when I was running my old STM business. And we've seen a very thankful level of success with HPA, and I'm very, very thankful for how this business has gone. And that also was born out of my previous business, STM, where probably, if I'm completely honest, for 2/3 of my 13 years owning and running that business, I was probably paying myself barely above minimum wage so that I could pour every single cent into my Evo 3 drag car. At the time, that looked like a completely stupid idea, but I built a lot of international recognition across that. And anyway, the anecdote I wanted to share was the very first time that my business partner, Ben, his partner, G, and I went to SEMA. We had no idea what to expect. And you'd reached out to me, and I can't even remember why now. And I got invited along to an AMS dinner at a place I'd never heard of called Talon. And we turned up not knowing what to expect. And I quickly realized that we were so far out of our league, it wasn't funny. And Tau's sort of, I don't know what it is now, probably still the same. It's kind of like a B/C list celeb hangout. And I got seated next to, I think Ivan at the time was your engine guy. Great guy, now works for Cannonball Garage, and I actually want to get him on the pod as well.
Yeah.
Great chats. Yeah, maybe you had like 3 or 4 tables. There must have been like 30 odd people there. Again, still not really understanding how I managed to get on the list for an invite. And anyway, we pick up the menu, and as soon as I see a bottle of champagne at 9,000 USD, I'm like, oh shit, we're in some serious trouble here. Maybe I could scrape together enough money for a starter. And fortunately, and I am very appreciative to this day, you picked up the tab. But that was a hell of an experience, and it sits with me to this day. So thank you for that, Martin.
Oh, you're welcome. I remember that vividly. We invited, it was like, we're displaying at SEMA, I think it was our first year, and we invited some of our dealers out to dinner. And yeah, I remember, I didn't know what to expect. We'll go to Tao. We made reservations. I remember sitting down and opening the menu. And I'm like, holy shit! Like, how are we going to pay for all this?
Okay, so it wasn't just me.
No. I was super stressed. Like, oh my god, we better get some good sales out of these meetings with dealers. Yeah, it was stressful for me too. Back then.
All right, good. Well, like I say, it's just certain things that will always stick in your mind, and that is definitely one of them. Look, Martin, it's been great to chat. I think we're sort of coming up around the 2-hour mark, so we'll move towards wrapping this up. And as usual, we've got the same 3 questions we ask all of our guests. The first of those is, what's next in the future for AMS? I feel like maybe we've touched on some of it, but yeah, what have you got for us?
Yeah, we're still looking kind of the next platform to kind of sink our teeth into and kind of take it to that next level. We really haven't decided yet. But for us, more of the picking some, higher volume cars. It could be trucks or cars, and bringing enthusiasts the kind of known quality, or the quality that we're known for, and the performance, where we're bringing parts in at a reasonable cost. We're not the highest out there. We want to be, bring good value, good price, the best product, and a package of, let's say, 5 or 6 parts where someone can, take their, a Ford Raptor and get another 200-300 horsepower out of it reliably for an affordable price. So that's kind of, we're looking at a lot of those vehicles now and expanding to a lot of other cars and trucks in that way.
I think that probably makes sense. I can't actually remember the guest we had on. I want to say Matthew Bernasconi from M26 Engineering, but I think I might be wrong. But that F-150, third-hand information, could be completely out of the ballpark. They're producing something stupid like 900,000 of those a year. It's just outrageous. So
I think it was 1 million a year. Yeah,
a million. Okay, well that's pretty close to 900,000. Let's split hairs. Yeah. Yeah, I mean, if you can capture a small percentage of that, you'd be probably pretty happy.
Yeah.
All right. Next question: is there any advice you'd give to a younger version of yourself to help reach where you are today quicker or sooner in your career?
Yes, and it's kind of so. I wish I had a mentor or sought out a mentor as far as like business goes when I was younger. Actually, this last year I did there's a local high school program where these students start a business from scratch, and I've been doing that the past year, where I'm one of the 4 mentors in this class, kind of guiding them, and that's been a rewarding experience to me, because I wish I had someone like that. And that's, if I can go back and know what I know now about business and things that apply to any business, not just our industry, that would have saved me many years. I would have been so much further ahead. I would have had less gray hairs. Not that I have a ton, but I would have definitely less gray hairs. But just common sense business advice, because I had to learn it the hard way, it's a good lesson, but it takes a long time. But I wish I would have sought out a mentor for business in general, for everything from finances, how to hire, all the kind of the building, the foundation of a business.
Yeah, that's totally fair. Before I speak to that, I just want to correct myself. It wasn't Matthew Bernasconi, it was Jeff Racer from Full Race Engineering who told me about the Ford F-150 development level. Anyway, yeah, you couldn't be more correct there. This has been spoken about numerous times on the podcast, but it's the classic entrepreneurial trap, where you're good at a thing, you start a business doing the thing, quickly realize that while you can do the thing, that only accounts to about half of the time that you need to spend, and the rest of it's all the business stuff that initially you probably don't have a clue about. So yeah, I think a mentor is a great idea. Courses around business development and business operation also are going to set you up for success. The way I kind of approached it essentially was partnering with someone who kind of filled in the gaps in my own personal skill set. There's not more than one way to skin the proverbial cat, I think, in that respect. But understanding that there's going to be things that you don't even know you don't know.
100%. I was lucky enough. Someone actually introduced me to this, like a business program. It's other business owners who get together, and there's like a guy who runs it, he's owned a business and sold it. And luckily enough, I was able to join that group. And I remember this is, I don't even know, maybe 7 years ago. I think our first meeting we had, I couldn't even sleep. There's so much that I was drinking from a fire hose at this meeting. Like oh my God, like I'm a disaster. What am I doing in business? So yeah.
I think it's important not to beat yourself up too hard on this stuff as well. It's a process to learn all this stuff, and it's just not going to happen overnight. I mean, you could liken it to building an engine or tuning a car. No one hits the dyno for the first time and cracks out a perfect calibration. It takes time.
Yeah.
All right, last question for today. If people want to follow you, see your products, reach out, see what you're up to, how are they best to do so?
Well, it's pretty easy. You can just go to amsperformance.com. It's our website. Also on YouTube, it's AMS Performance, or any of our social medias or Facebook. Just look up AMS Performance, and it's pretty easy to find.
Perfect. Well, as usual, those links will all be in the show notes to make it easy for people to find. Look, Martin, it's been great to get a bit more insight into the background. You're definitely a company that I looked up to when I was starting STM, and you guys have just continued to excel, exceed, and break records left, right, and centre. So long may it continue. Thanks for your time today.
Well, thank you. And thank you for everything you do too. I appreciate it.
I hope you've enjoyed this episode of Tuned In, and don't forget, by using the code podcast500 at checkout, podcast listeners can get a huge $500 off our VIP package, which includes over 40 current courses, as well as a long list of courses to be released in the future. As a VIP, you'll also get lifetime access to our members-only webinars and our community forum. Lastly, we'd love it if you could leave a review or comment on your preferred podcast platform. Your feedback really helps us to reach a wider audience, which in turn allows us to continue bringing you more high-quality guests. As a thank you, each week we'll randomly select a review or comment from Spotify, Apple Podcasts, or YouTube, and send the winner a free HPA t-shirt shipped anywhere in the world. It's also a great place to ask any questions you might have too, and if your review or comment is chosen, I'll do my best to answer them directly. So this week, a big shout out to Beaches to Mountains from Spotify, who said I could listen to these tuning talks every day for the rest of my life happily. Well, I am pleased to hear that you're getting so much happiness out of listening to our podcast, and we're going to just keep on producing them. If you want to reach out with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.